Okay. In Unit 5, we're talking about probability and statistics on an intro level. Next year in algebra, you will take a more in-depth look at these concepts, but we're just kind of walking in and just seeing how we feel about it this year. I don't think this unit is particularly difficult. It's only 4 lessons long, so most kids pretty much, they do really well in this unit. I expect you guys will too. So we're going to begin talking about set theory. Okay, a set is a well-defined collection of objects. We call them elements. Okay, so example here, like a set of vowels. Okay, we don't want to say just letters. We want to be very specific, and we'll say vowels instead. And then we can say a universal set is a set that contains everything of that element. So in my example, I did single-digit whole numbers. That is 0, 1 through 9. Okay, that encapsulates every single-digit whole number. A subset is just a specific part of a universal set. So going off my universal set here, I said my subset was every even single-digit whole number. 0, 2, 4, 6, and 8. It's not everything, it's just a part of it, just a subset. So we have some relationships of sets. An intersection is an overlap of 2 or more events. We think of these we think of and for this. And the symbol is that. Okay. Now, some of you may recall from another unit where we had P and Q, and it was the up arrow. Well, math, we have to change everything all the time, right? You can't get used to one symbol because we got to make it more difficult. So instead of an up arrow, it's just an up N. It's kind of like an N. So you can say P and Q that way. So here we have an example. Here is set C and here is set D. All right. So to do these, it's often easiest to make a Venn diagram. That's bad. It's a bad one. Not enough space in that one, man. Let's make it bigger. Better. Okay. I will call this left circle set C and this one D. Okay, so we have this overlap, right? What existed in both C and D? Well, it was 7. 7 exists in both of those circles. So we're going to make sure that we need to exclude items in the set that don't go to the other one. C has 8, but D doesn't have 8, so it must live over there. And over here, D needs to have the 11. But where they overlap, where something is in both, that's going to be 7 in the middle. So you can say C and D, 7. It's just what is in C and D? 7. Okay. A union is a brand new set that contains all elements of 2 or more sets. This is an OR statement. Come on, computer. Come on, man. You can do it. You can scroll up a little bit. No, you're gonna fight me? I'm not re-recording this. We're just gonna do it live, man. I have to get the mouse. Aha. So it is a new set that contains all elements of 2 or more sets. Think of unions as ORs, or adding statements, and the symbol is an upside down U. So again, before we had P or Q, right? That was a down arrow. Well, this is just a downward, kind of like a U thing. Okay. So these are going to be adding, really. C or D. Well, we have the exact same thing. We could draw, and we know what this looks like. And now we'll just say, okay, what was in C or D? 7, 8, and 11. Those are elements that are in both. It's both categories. I'll take both. I'll take C or D. Those are all the things. Oh, can't use my finger apparently. Gotta use the mouse. The complement is the probability that something does not happen. So we have 2 ways we can write that. We call these events. So this says event A. So it's A with a little dash, a little tick, or A with a bar over top of it. Both of those mean not A. So if my universal set is once again 0 through 9, and A is 2, 5, 7, 8, 9. Well, what is not A? Well, let's go in and we can cross off things, right? 2 was an A, I don't want that. 5, 7, 8, and 9. So what was in not A? 0, 1, 3, 4, and 6. Those are things that are not in A. That is the complement of it. And we use, when we talk about sets and things like that in set theory, you might see these squigglies. They're just brackets. So you can use a lot of different kinds. You can use this, 1, 2 example, okay? You can use hard brackets like that, okay? I'm gonna use the squiggles. You feel free to choose your own bracket adventure. It's an exciting thing. Okay, so here's an example. Got a large bag of marbles. A lot of different colors in there, blue, green, orange, and pink. A small bag holds some marbles that has different colors, red, green, yellow, and orange. Define the universal set. Okay, so our universal set is gonna be all elements. I see that the big bag had blue. It also had green, orange, and pink, I believe. Yep. The small bag has red, and then it has green. Okay, well the big bag already had green. I don't need to write it twice. Okay, I'm not gonna double dip on colors. Yellow and orange. Did I already have orange? I did. Okay, I don't need to repeat elements. Once it's already counted, it's good. Now, I thought it was gonna work that time. I don't know why. Define the 2 subsets. Okay, so our large bag. That one had blue, green, orange, and pink. And the small bag had red, green, yellow, and orange. So when I make the universal set, I don't need to double dip. But if I'm talking about the 2 subsets, well, I can't just ignore that the small bag had green because the big one did too. I need to make sure that I have both of those. And then draw a Venn diagram to represent. Okay. Call this one the large bag and this one the small bag. Okay. Now, it might be helpful to start in the middle, start in the overlap. Maybe. That's where I would start. Both of these bags had green and they had orange. The large bag also had blue and pink. And the small bag had red and yellow. Okay. So again, between those sets, I have all 4 colors in the large bag and I have all 4 colors in the small bag, but where they overlap, that's right there. So lastly, we're gonna find the intersection and the union. The intersection that's going to be where they overlap. That was green and orange. And then our union, sorry. Remember that was an or statement. Okay, so that's everything. That's all of it. It's gonna be green, orange, red, yellow, pink. What else is in there? Blue. I think that was it. All elements. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So what was in the green or the large bag? Those things, with no double dipping. I already counted them. Suppose a universal set contains of all the single-digit positive whole numbers. 2 subsets are created from the universal set. The set of all even numbers, we're going to call that set E for even, and the set of 2 multiples of 3, okay, M for multiples. Define the universal set. So everything in this set, the universal set, all single-digit positive whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so those are all of those. Define the 2 subsets. Okay, E. That was the even numbers, right? Okay. 0, 2, 4, 6, and 8. And the other set was m, the multiples of 3. No, yes, 3 is a multiple of 3, 6, and 9. Let's draw a Venn diagram to represent these sets. Okay, zoom, make it bigger. So I had evens over here, and I had multiples of 3 over here. I always start where the overlap is. So even numbers and multiples of 3. What's in both of these? I see just 6. 6 is even, and it's a multiple of 3. The rest of the evens, 0, 2, 4, and 8. And then multiples of 3 had 3 and 9. Okay, so every element though is not there. My Venn diagram's perfect. I have all of the numbers where they should be, but there are some parts of this set that don't fall into these two categories, right? I had, what about 1? What about 5? What about 7? Those don't fit into either of these categories. So they just exist outside of it. They still need to be represented, but they just don't fit into those categories, so they're on the outside. Using this Venn diagram, we can actually probably find all of our answers to the rest of these. Remember, this is read as not E. So, not E, I want everything that's not in E. 39157. Find E and M, okay? So that's what is in both E and M? 6. And then, okay, so this one's a little tricky. If I read this first, it says E or M. Okay, so what is an E or M? All of these would be the thing, but that says not. So it's not E or M. So E or M not. Well, what is not neither of those two categories? 157. Oops, come on, man. Don't be sloppy at the end. Yeah. Okay, there you go. I think that's just it for lesson 1. Yeah, nice and easy, right?